These videos are for February 7th, February 8th, looking at solving quadratic equations and also determining the nature of a function's roots and zeros. To start, I want to say it was today, what we looked at is first square roots, simplifying square roots. And I started with square root of 20, determining if we could simplify square root of 20. And the way we can simplify this, if we think about perfect squares, so like 1 is a perfect square, although one goes into every number. That's what I'm trying to say. The next perfect, 2 squared, 4, 3 squared, 9, 4 squared, 16, 25, so on. These are our perfect squares. And if a number under a radical has a perfect square that goes into it as a factor, then we can simplify it. So for example, we can write this as square root of 4 times 5. We could also write this as square root of 10 times 2. But square root of 10, that doesn't simplify. Square root of 2, that does not simplify. However, we know square root of 4 simplifies. That simplifies as 2. So this could be written as 2 square root of 5. Similarly, if we had like 27, 9 times 3, we could say this is 3 square root of 3. Another thing we could also do with square roots, if we had like square root of negative 11, if we have a negative under the square root, we can take that out by putting I and then keeping that square root. So these are things that we're going to have to recall when we are solving some of these equations. Now, let's go ahead and solve these. So here, we want to solve this equation. First, I would always look, see if you can factor it. So here, since there's no number in front, we can say, are there 2 numbers that multiply to give us 36, that add to give us negative 13? Yes, negative 9 and negative 4, that works. So this would be 0 times x minus 9, x minus 4. And then since we already have 0, we can say x minus 9 equals 0. And those would be our solutions. I'm going to do this just so we have a divider. Let's see what happens with this next one. If we subtract 10x, get 0 on one side, so we can factor. Now in our class, what we've done a lot is AC method, see if it works. So we can multiply by 6. Now we try to figure out, are there 2 numbers that we have a product of negative 30? Those same 2 numbers have to sum to negative 13. Negative 15 and 2. So this would be x minus 15, x plus 2. But we would multiply by 6 here, so we need to divide by 6. Simplify the fraction. 15 over 6. 3 goes into both of those numbers. So this would simplify as 5 over 2. 2 over 6. That simplifies to 1/3. And then after simplifying, these go in front of the x. This is why I do not like the AC method. There's a lot to remember. But it still gives us our factors. And now we can set each piece equal to 0 since we have factors that multiply together equals 0. So we can say, add the 5, divide by 2, you should get x equals 5 halves. Subtract the 1, divide by 3. Now I should say something here. What we say here, and this is AC method, I'm just going through these quickly because these are something that we should already know. Here, what we say, because these are both real values, we say that we have 2 real solutions. Same thing here. These are values that we can put on the x-axis. So these are 2 real solutions. 2 real solutions. And we'll see what happens if it's not a real solution. Here, if we want 0 on one side, we can subtract 2x squared, add the 4. Careful with your algebra here. So we get x squared plus x. Negative 46 plus 4 would give us negative 42. We don't have a number in front, so we don't have to worry about AC. We can just do product of negative 42. That adds to 1. Seven times negative 6 would give us negative 42. 7 plus negative 6 would give us the 1, which is in front of x here if you think about it. And again, we have two real solutions. Get rid of this lead. It's driving me crazy. All right, one more and see what happens. See what happens here. Add the 8x. Minus 2x plus 3. Now we could try product sum. Two numbers that multiply give us 3 that add to negative 2. That's not going to work though. We can't do it. No AC because there's a number in front. So what do we have to do? We have to use our beloved quadratic formula. Not an assessment, you will need to know this. Here's our quadratic formula. So we plug those into here. A, value in front of x squared, so that's 1. B is negative 2. C is 3. Now, careful with quadratic formula. Parentheses are your friend. Simplifying and neatness are your friend as well. So here, b is negative, but we have a negative b there. So a negative and a negative, that would make this a positive 2, plus or minus, square root, b squared. Always use I recommend using parentheses whenever you substitute. A is 1, c is 3. All over 2 times a. Now the key thing here is looking at and thinking, can I simplify? Is there something that I can do to simplify? So let's look. So let's look under the radical. Negative 2 squared would give us 4. 4 times 1 is 4, times another 3 would give us 12. Four minus 12 would give us a negative 8. Now again, is there something that we can do here to simplify? Can the square root of negative 8 simplify like what we did up here? Well, first, we can take out the negative by replacing that with I, because we have an imaginary number. If there's a negative under the square root, then we can take it out, put I, and we continue up here. Then we also want to figure out, are there perfect squares that go into 8? Well, 4 goes into 8, so we can say this is I under the square root, 4 times 2 all over 2. And now what we can do is take the square root of 4. We know the square root of 4 is 2, so this would be 2i. 2 goes in front of the I. Square root of 2 over 2. Now we have something plus or minus something in our numerator. What we can do is break up this fraction and help simplify, further simplify. So we can say 2 over 2 plus or minus 2i squared root of 2 over 2. Now we can say 2 divided by 2 is 1. Here, what's going to simplify? These 2's divide out. So we're left with 1 plus or minus I square root of 2. That would be our solution. And because we have 2 of them, we have 1 plus I square root of 2, 1 minus I square root of 2. We say we have 2 complex or imaginary solutions. So I've gone through 3 main methods in terms of solving our quadratic equations. Here we did like a product sum. For this second one, we did AC method, here quadratic formula. That's what the rest of this is doing. I'm going to go ahead and turn to the next page. If you have questions, pause, rewind, ask me in class, outside of class, things like that. Here are the solutions for the next page if you want to pause it. And real quick, I'm going to go here. So work through these real quick. If you try AC method here, you would get x squared plus x plus 2 equals 0. You try to factor that, it doesn't work. Instead of using this equation for the quadratic formula, you have to go back to the original. So you have to go back here and say A is 2, B is 1, C is 1. Okay? And again, the quadratic formula is here if you need it. Final thing. Here it's asking for the zeros of the function. All you would do if it's asking for the zeros is you set your function equal to 0 and solve by either product sum, AC method, or quadratic formula. So if it's asking for the zeros of a function, set your function equal to 0 and solve. Hopefully that's helpful. If you have questions, please let me know. Ask me through the Remind app, all of that. This will be the only video for February 7th, February